Hello all, welcome to the final project demo for course ECEN 5713 Advanced Embedded Software Development. Our project is Crash Detection and Notification System using BeagleBone Black. My teammates are Ganesh and Pranav. The motivation for the project is there are around 5 million accidents in US each year with around 1% of them being fatal. Most injuries are due to extreme deceleration and other physical events occurring from them. Response time to these accidents is a critical factor. Emergency services would require accurate information regarding the accident location and the time of event. Our project aims to gather information during an accident from an onboard accelerometer and GPS sensor and relaying the data to emergency services in the form of notification email via cloud. We are realizing the above concept using BeagleBone Black as the hardware platform, BuildRoot as the target build system. We have interfaced the BeagleBone Black with GPS and accelerometer sensor. Custom UR driver is developed to interact between the user space and the physical hardware. Once the crash is detected, we are sending the GPS location in the form of latitude, longitude, along with accelerometer data causing the crash to the cloud server using socket programming. My contributions involve building a compatible image for BeagleBone Black. I worked on the hardware bring-up of the BeagleBone Black with BuildRoot as the target build system. Initially, I used the serial to TTY converter to get the debug dump on the serial terminal. This is used to verify that the BeagleBone is booted using SD card and not eMMC. I enabled SSH access on the BeagleBone Black so it is easier to transfer files to the board. By default, BeagleBone has only UART0 enabled, which is used for dumping log messages. Since we are developing a custom UART driver, we had to enable the other UART ports. To enable this, I used a custom UART patch. This patch contains a compatible string which matches the string value used in the driver code. This allows the probe function to find and attach the hardware driver to the port. All the serial ports are enabled after applying the patch. Additionally, I worked on scripts to compile the user space accelerometer and GPS program and install the executable on the kernel image. I worked on scripts to load and unload UR driver module. I worked on enabling internet access on BeagleBone to communicate with ThinkSpeak over socket. Finally, I worked on socket programming to send the crash data to ThinkSpeak cloud service and notification system. Some of the challenges I faced during the project is the one is with the custom UART patch. It was not compatible with the latest BuildRoot version. It required me to migrate to older BuildRoot version. Cross compiling of each of the user space program required me to learn about compiler flags. An additional challenge which I faced was during socket programming while sending the data to ThinkSpeak cloud server. I was not able to connect to ThinkSpeak IP. This was solved by making a router as the gateway. Some of the lessons learned during the project are BeagleBone Black hardware bring up, setting up cross compiler, enabling SSH access, scripts to bring in user space code to kernel image, scripts to load driver modules, establishing connection with cloud and sending data to cloud using REST API. The most important ones are the compiler flags. The static option during compilation links a program statically and it does not depend on dynamic libraries at the runtime in order to run. And the lm option during compilation is required when using math.h as math.h is mapped to libm. This additional flag is required. Let's now look into the demo. Hello all, this is our project setup. We have implemented our project on BeagleBone Black. We have interfaced accelerometer sensor over I2C, GPS sensor over UART. We have enabled SSH access on the board. Here is our executable. We shall run it now. We can see the acceleration data is being read. I shall now simulate a crash by inducing a deceleration. We see that the crash is detected. The socket program sends the GPS coordinates to the ThinkSpeak server. This is the ThinkSpeak's channel. We can see that the crash data is sent from the board is registered here. An alert email is triggered immediately on change, which we can see here.